All right, let's jump right into this explainer. Today, we're bridging that massive gap between theoretical IS codes and the rigorous ground-level execution we actually deal with on Indian construction sites every single day. We're breaking down a critical workflow that site engineers, QAQC pros, and contractors tackle all the time, yet somehow, it's still frequently underestimated. I'm talking about the absolute non-negotiable checking of brick and block masonry before any plastering even begins.
Right off the bat, we need to completely crush a very common site misconception. Here is the golden rule of execution. Plastering is absolutely not some magic finishing activity meant to hide rough or poor blockwork. Think of plaster as just a final skin. If the skeleton underneath your masonry is weak, uneven, or out of plumb, well, that plaster is literally guaranteed to fail.
So consider this our quality assurance plan for today. We're going to cover why masonry matters, the materials and technical theory behind it, wall alignment and bonding, surface and MEP preparation, and finally, we'll look at some common plastering defects. Let's get into it. Section 1, Why Masonry Matters. Let's talk about why your rigorous QA/QC clearance here is simply non-negotiable. You've got to think about the cascading effect of poor masonry. Imagine a wall is built out of plumb. A mason might just try to compensate by slapping on extra plaster thickness on one side to make it look straight, right? But doing that drastically increases the dead load on the structure, and it needlessly bumps up your cement and sand consumption. Even worse, overly thick plaster is the primary culprit for shrinkage cracks and a wavy, totally unacceptable finish. Thorough checking up front saves you massive amounts of material and prevents highly expensive rework later. Moving right along to Section 2, Materials and Technical Theory. This is where we anchor our daily site execution directly to the Indian standards. According to IS 2250, mortar is defined very strictly as a homogeneous mixture of cementitious materials, water, and inert materials like sand. You absolutely cannot permit random, uncontrolled mixing on site. If that mix isn't truly homogeneous, you're going to generate weak pockets in your bed joints, and that ultimately compromises the structural integrity of the entire wall. It's a huge risk. Furthermore, before we even think about applying it, we have to understand setting. Look, setting isn't just the mortar drying out. It actually involves vital physical and chemical changes due to the hydration of hydraulic constituents. If your mortar loses its moisture too rapidly, that chemical reaction just stops dead in its tracks. And what are you left with? A powdery, completely useless joint. Now, depending on your approved project specifications, you have to verify exactly what type of mortar is being mixed out there. Cement mortar is straightforward, just cement and sand. But composite mortar introduces lime or other additives to improve workability and water retention. If you use the wrong mix design for a specific application, you are looking at immediate bond failure. IS 1661 gives us some critical definitions we really have to enforce. While fineness modulus helps us grade our sand, suction is arguably the real game changer here. Suction is essentially the background property that determines how fast a wall absorbs water. If your clay bricks are high suction, they're going to pull water directly out of your mortar before the hydration process can even finish. This is exactly why thorough pre-wetting of clay bricks is a mandatory site practice. Don't skip it. Okay, Section 3, Wall Alignment and Bonding. Let's translate all this theory into our step-by-step physical checking workflow. Systematic verification is everything. First, confirm you're actually using the latest good for construction architectural drawings. Check your horizontal alignment using a line dory and spirit level. Verify the verticality with your plumb bob, and cross-check those diagonal measurements to ensure you have perfect right-angle room corners. Remember, even a minor deviation out of plumb completely sabotages your tile alignment, your door frame fixing, and your cabinetry layouts later down the line. It's a domino effect. And here is a massive, and I mean massive, frequent site error. Masons leaving vertical joints totally unfilled, or letting them align continuously in a single vertical plane. Doing this completely destroys the interlocking bond of the masonry. It creates these weak, continuous vertical lines that practically guarantee severe shrinkage cracks. Proper staggering of vertical joints is absolutely non-negotiable. On to Section 4, Surface and MEP Preparation. Once the masonry is up and structurally sound, coordination becomes our #1 priority. You have got to coordinate flawlessly with your mechanical, electrical, and plumbing teams. Never, ever allow chasing, cutting grooves into the wall for conduits after the plastering is completed. It totally shatters the finish.
Also, check your structural drawings to ensure chicken mesh or GI mesh is firmly nailed right at the junctions where your RCC columns meet the blockwork. Because those materials expand and contract at different rates, that mesh is literally your primary defense against differential shrinkage cracks.
To get a permanent bond, plaster requires a mechanical key to grip onto. Smooth RCC surfaces must be thoroughly hacked or roughened up. Any hollows in the masonry need to be dubbed out. And most importantly, you must mandate extreme surface cleanliness. All that shuttering oil, dust, and loose mortar projections, they have to be wire brushed completely away. Plaster will simply debond and peel right off if you apply it over a contaminated background.
Section 5, Plastering Defects and Failures. So what are the severe, highly expensive consequences of ignoring all these QA/QC steps we just talked about? According to IS 1661, skipping your preparation leads directly to defects like map crazing. That's that really unsightly, haphazard pattern of hairline cracks you see across a finished surface. You'll also encounter blistering, which is where intense local forces actually cause the final coat to swell and rupture. Both of these disasters happen simply because there was an inadequate mechanical key between the plaster coat and the masonry background.
Now let's look at two major chemical nightmares: efflorescence and sulfate attack. If you plaster over a wall that's suffering from rising dampness, or if you use bricks with a high sulfate content, the moisture acts as a catalyst. Efflorescence leaves these stubborn, white, powdery salt deposits all over your finish. Meanwhile, a sulfate attack is even worse. It causes a volumetric expansion that physically disintegrates your mortar and plaster from the inside out. No one wants to deal with that. But the ultimate catastrophic failure is the total loss of adhesion, complete bond failure. If you skip curing the masonry, or forget to rake the joints, or ignore hacking the RCC faces, the plaster simply won't bond. You're going to catch this during checking as hollow-sounding patches when you tap the wall, which eventually leads to substantial flaking and peeling, and the only way to fix it, scraping it entirely off and starting over. That is a massive, totally avoidable blow to your project budget.
All right, let's bring it all home. Final checklist and conclusion. Let's condense all these standards into a practical, hard-hitting, on-site checklist.
Think of this as your mandatory clearance checklist. Verify the line, level, and plumb verticality. Ensure all those MEP conduits are fully chased and grouted. Confirm the bed joints are raked and the RCC faces are properly hacked. Verify your chicken mesh is securely nailed at all the junctions. And finally, ensure the wall is thoroughly cured, pre-wetted, and spotlessly clean. Only after documenting these specific approvals should you ever sign the clearance for the plastering agency to begin.
I want to leave you with this final thought. Plaster will only hide poor workmanship for a very short time. When the moisture finally dries, the shrinkage begins, and all those structural forces start acting upon the wall, will your underlying masonry pass the test? True quality in civil engineering is always built from the inside out. Make absolutely sure your hidden foundation is flawless before you ever allow it to be covered up.